Yes, I welcome you, dear viewers. In our last or previous lesson, we were looking at De Moivre's theorem and how it can be used to prove trigonometric identities and how it can be used to find the roots of the equations. But this time around, we are going to look at the locus of a complex number. When we say locus, we're trying to look at the equation of a set of points which represent a variable complex number or the path traced. And for our level, it may be a circle or it may be the equation of a straight line. So we are going to have this. We are going to have this. We are going to see how we can use these complex numbers to get the equations of the circle and the equation of the straight line. But also, of course, we shall be meant to sketch these graphs or these loci. One is a locus, but when there are many, they are loci. And it's going to really work for us. It's going to really work for us. So let's see examples of determining the locus of a complex number. Examples, meaning as of now, as we push this topic, we should be able to know how the circle, the general equation of the circle, you should have some information about the circle. Of course, a straight line, you've heard of a straight line from all level up to now. So with a locus, let's have some examples done. One, given that magnitude of z minus 1 minus I, which is equals to magnitude of z minus 2. Find the simplest form in the simplest form the Cartesian equation of the locus. So when you're given this, okay, it is very simple in a way that we need to know what this one represents. So the most important thing to do is to let our z to be equaling to x plus iy, which is the general form of a complex number. It means that if z is x plus iy, then we shall be having x plus iy then minus 1, then minus I, magnitude is equal to magnitude of x will be, rather z will be x plus iy, then minus 2. So this will be x, correct the real, which is x minus 1, plus imaginary is y minus 1 after factorizing, then I. This is equal to, correct the real, to be x minus 2, then plus iy. So the magnitude is equal to the square root of the real squared. So it will be x minus 1 squared plus y minus 1 squared. And this is equal to, the magnitude of this side will be the real x minus 2 squared plus y squared. When you square both the sides, the square roots will go. So we shall have x minus 1 squared plus y minus 1 squared is equal to x minus 2 squared plus y squared. So when you look at this, if you try to expand it, you're going to have you're going to have x squared minus 2x plus 1 plus y squared minus 2y plus 1 is equals to x squared minus 4x plus 4, then plus y squared. So if you look at this, x squared and y and x squared will go, y squared and y squared will go. So we shall have the simplified numbers minus 2x minus 2y plus 2 this side is equal to, this side we have minus 4x plus 4. Bring that 2x minus 2 is equals to 2y, and therefore when you divide through by 2, you get your y as x minus 1. So if they want you to, this is the locus, this is the equation of the straight line. So if they want you to describe the locus, they say describe, you will say that the locus is a straight line with gradient 1, because this one is in the form y is equals to mx plus c. So we can easily get a gradient, and at the same time, you can easily get the intercept, right? Yeah, then from here we are going to have some other example. We're going to have some example too. Given that magnitude is equals to 2, z plus I, show that the locus of P is a circle. Show that the locus of P is a circle. Okay, so now here we need to be knowing the properties of a circle. Since we are to show that that the locus is a circle, now, of course, the first step would be to let z to be equaling to x plus iy. Okay. Right. So here, if z is x plus iy, so we shall have that magnitude x plus iy minus 2 is equal to 2 x plus iy, that is z, then plus I. So when you look at this, it means that we shall have the magnitude. You correct the real, so it is x minus 2 plus iy is equal to 2. Correct the real is x, then plus the imaginary, which is y plus 1 into I. So to remove this, we have to take the root both sides to get the magnitude. So we shall have x minus 2 squared then plus y squared is equals to 2, right? Into the square root of x squared plus y plus 1 then squared. When you square both sides, we shall have x minus 2 squared plus y squared is equals to 4 into, because the square will affect even a 2, x squared plus y plus 1 then squared. So looking at this, here we shall have x squared minus 4x plus 4 plus y squared is equals to 4x squared, then this one also, first square this, then multiply 4, it will be plus 4y squared plus 8y, because it will be 2y times 4, 8y then plus 4. All right. So working on this, we shall have and bring everything this side. So 0 is equals to 3x squared plus 3y squared plus 4x plus 8y. A 4 and a 4 will cancel, right? When you divide through by 3, you will have x squared plus y squared plus 4 over 3 x plus 8 over 3 y is equal to 0. This is sufficient enough to show you that it is a circle, because a circle takes the form, so which takes the form, the circle is x squared plus y squared plus 2gx plus 2fy plus c is equals to 0. This is the general equation of a circle, and that is what you can note. If you have not covered circles, you can note this. So with this, of course, since a circle is characterized by the center and the radius, it means that we have to find the center and the radius. The center of a circle is the coordinate -g, -f. We can also note that, meaning that we can compare this equation with this one that we've gotten, so that we get the value of G and F, and then we get the center, then we also get the radius. So it means that by comparing, our 2G will be equaling to 4 out of 3. If you compare the coefficient of X, will be equaling to 4 out of 3. This one will give you your value of G as 2 out of 3. 2 out of 3. Okay, then when you compare the coefficient of Y, here we shall have 2F is equals to 8 out of 3. 8 out of 3. So your value of F is going to be 4 out of 3. Then now looking at this, we can get our center. Since it is negative G, it will be negative 2 out of 3, comma, negative F, which will be negative 4 out of 3. That is the center. Then also, the radius of a circle is given by the square root. It's given by the square root of G squared plus F squared minus C, whereby C is the value that is supposed to be here, but we don't have it, so C is 0. So the same as the square root of G squared, which will be 2 out of 3 squared, plus F squared, which is 4 out of 3 squared, then minus 0. So the radius will be, this is 4 over 9 plus 16 over 9, which will be 20 over 9 under root. So it is going to be root 20 out of 3, but root 20 the same as 4 times 5, so it is going to be 2 over 3 root 5. That's the radius. So if they want you to show that it is the circle, you'll say, yeah, you will say that the locus is a circle with the center this and radius this. If the question wanted you to plot it, if the question wanted you to sketch it, if we are taught to sketch, it means that you would have, when you're sketching complex numbers, we have real, we have imaginary. So first, plot the center. When you plot the center, negative 2 over 3, negative 4 over 3, if this is my negative 2 over 3, and this is my negative 4 over 3, maybe this is 2 over 3, 4 over 3. So if that is 2 over 3, sorry. Yeah, 4 over 3. So my center, if my center is here, this is my center, negative 2 over 3, C over 3. Then you move the radius, the distance from the center to the circumference of a circle, meaning that from here up to somewhere is this unit. So we have to sketch. So I can have this, maybe my radius is this. Then you plot, you just make it equal throughout. So that would be my circle, because after getting the center, you can now move any unit. You can estimate the radius, okay? And then you sketch. Let me do some other numbers here. Meaning that, let's say, determine the locus of Z if Roman 1 magnitude of Z minus 4 is equal to 3. Roman 2 argument of Z plus 2 is equals to pi over 6. Roman 3 argument z minus 1 is equals to pi over 4. Normally 4 argument z minus I over z plus 1 is equal to pi over 3. Of course, if I do this, you should be in position to do this. So I'll do this, this, and this. Okay. So the first one, you have said that in all cases, let my z to be x plus iy, implying that magnitude of x plus iy minus 4 is equals to 3. So correct the real x minus 4 plus iy is equals to 3. To get the magnitude, we take the square root and then we square the real part is equals to 3. Now to remove the square root, of course, we shall square both sides. So we shall have x minus 4 squared plus y squared is equals to 9. When you square that one, you get x squared minus 8x plus 16 plus y squared is equals to 9. You can bring a 9 this side, so it will be x squared plus y squared, right? Minus 8x plus 7, because it will be 16 minus 9, which will be plus 7 is equals to 0. So that is the locus that we have. 2, I've said that argument of z plus 2 is pi over 6. Well, so it means that our argument x plus iy then plus 2 is equals to pi out of 6. So this is argument correct real x plus 2 then plus iy is equals to pi over 6. But to get argument, we say that it is the tan inverse of y over the imaginary part over the real part, x plus 2. So that one can be clearly understood when someone has gone through that work of getting the arguments. So you can take the tan either side, so that y over x plus 2 is equals to tan pi out of 6. Tan pi out of 6. Pi over 6 is 30, so tan 30 is 1 over root 3. So y over x plus 2 is the same as 1 over root 3. And 1 over root 3, if you rationalize, it will be, if you multiply root 3 up and down, it will be root 3 out of 3. All right, so if you cross multiply, you'll have 3y is equals to root 3 x plus 2 root 3. So looking at that, you can get your y as root 3x over 3 plus 2 over 3 root 3. So one can factorize out root 3 over 3 and remain with x plus 2. However, if it is here, you can easily define it and easily tell that this is the straight line with the gradient root 3 over 3. and y-intercept 2√3/3. So it can easily be sketched because you already know the intercept. If I'm to sketch that one, I have real, I have imaginary. The intercept is 2/3√3. I'm assuming that it is somewhere like here, 2/3√3. And since it is positive, it means that my value will be, my line will be like that. So whenever you sketch something, you have to label it. Y is equals to √3/3 x plus 2, something like that. So let me do this part 4, then maybe I pick some other number at random and we see. They gave us argument of z minus I out of z plus 1 is equal to pi/3. So it means that here we shall have that argument x plus iy minus I over x plus iy plus 1 is equals to pi/3. So this is the argument. When you're dividing the argument, we say that it is the same as x plus y minus 1i then minus argument, because you are dividing. So it will be argument x plus 1 then plus iy, and this should be pi/3. So looking at this, to get argument of this, we take tan inverse of x over, no, tan inverse of y minus 1 over x minus tan inverse over y over x plus 1, and this is equal to pi/3. Now, when you reach at this point, this is a point where we have to, this is a point where we have to let, right? So I can let, tan A, I can let tan inverse of y minus 1 over x to be A, and maybe tan inverse of y over x plus 1 to be equaling to B. All right, implying that if you have this, it means that tan A is equals to y minus 1 over x, while tan B is equals to y over x plus 1. So if you're having this, since this is the whole of this one, I let it to be A, and this one I let it to be B, so it means that I have A minus B is equals to pi/3 when you take tan both sides. So tan A minus B will be equaling to tan pi over 3, right? So it would imply that of course tan A minus B is the same as tan A minus tan B out of 1 plus, since we are subtracting, so we shall add 1 plus tan A tan B, which is equals to tan pi over 3. Tan pi over 3 is the same as root 3. Okay, let me say, okay, let me keep it as tan pi over 3. So tan A is y minus 1 over x minus tan B, which is y over x plus 1 out of 1 plus tan A, which is y minus 1 over x, then tan B, which is y over x plus 1, and this should be equal to tan pi over 3, which is root 3, tan 16, root 3. So now, when you simplify this, we shall remain with y minus x minus 1, right, out of, when you simplify this, take LCMs, do all the necessary operations. Here, take the LCM up, take the LCM down. After multiplying this, of course, you need to first open here, then you check the LCM, you take the reciprocal. So you're going to get x squared plus y squared plus x minus y is equals to root 3, implying that if you cross multiply, you're going to get root 3x squared plus root 3y squared plus, this is a root 3 plus, this will be x. So I can factorize out, because I'm going to bring this x this side, then I say x, then minus root 3 plus 1, then y plus 1 is equal to 0. So when you divide through, you're going to have x squared plus y squared plus 3 plus root 3 out of 3, because I'm dividing by root 3, but then you have to rationalize. So times x minus 3 plus root 3 out of 3, then y, then plus root 3 over 3, because we divide by root 3, you rationalize, so is equal to 0. So the locus is a circle with a center. Now you can compare with the main equation and get the center and then the radius. Radius will be root 2 out of 3, the whole thing, 2 over 3. So that's why I want you to compare with the general equation of the circle and you get the final expression. Then the center would be negative 1 over 6, 3 plus root 3, that is the first value, then 1 over 6, 3 plus root 3, that is another value. So this is the center. Compare and see if you get this, but that is the approach that we do take. So you can find this locus for your case. Find a locus of argument of z over z minus 6 is equals to pi out of 2. So I want you to find that locus. All right, you can find that locus. Then I have some number which I want to complete with. I have to complete with these two, actually. They can say, describe and illustrate on the Hagen diagram the locus given by, if we have z plus I over z minus 2 is equals to 3. Then the second one, you will do it because it corrects with what we've talked about. Argument of z plus 3 is equals to pi over 6. So my interest is this. Now, when you're having such a number, you can use the fewer steps to get the final answer. You can use fewer steps to get the final answer. How do we go about it? Of course, if you have to let z to equal to x plus iy, implying that x plus iy plus I over x plus iy minus 2 is equal to 3. So when you correct like terms, you'll have x plus y plus 1 I over x minus 2 plus iy is equals to 3. So it would imply that the square root of x, because the magnitude, this is the magnitude of this over the magnitude of this. You separate the magnitude, so it is the square root of x plus y plus 1 I. Of course, you square, then square also here over the square root of x minus 2 squared plus y squared is equal to 3. So when you cross multiply, you get the square root of x squared plus y plus 1 square is equals to 3. Then the square root of x minus 2 squared, then plus y squared. When you square both sides, the square roots will go. So you have x squared plus y plus 1 squared is equals to 9 into x minus 2 squared plus y squared. But that 9 is affecting everything because we squared both sides. So this one will come to x squared plus y squared plus 2y plus 1 is equals to 9 into x squared minus 4x plus 4, then plus y squared. So when you open the brackets here, you're going to get x squared plus y squared plus 2y plus 1 is equals to 9x squared minus 36x plus 36, then plus 9y squared. When you bring everything this side, you have a 0 this side. So 0 will be 8x squared plus 8y squared, then minus 2y, right? then minus 36x, right? Then one will come this way, so we shall have plus 35. So when you divide through by 8, you're going to have x squared plus y squared. When you begin with the 3, it will be minus 9 over 2. If you divide through, because it will be 36 over 8, you can divide through by 4. So x then minus 2 over 8, that is minus 1/4. Then y, then plus 35 over 8 equaling to 0. So that is my equation. It takes the form of x squared plus y squared plus 2gx plus 2fy plus c, which is equals to 0. So by comparison, you can see that 2g is equals to negative 9 over 2. Therefore, g is equals to negative 9 over 4. 2f is equals to, when you compare the y, shall be having negative 1/4. Therefore, f is equals to negative 1/8. So the center C is given by negative g, negative f. So C will be given by negative g, which will be 9 over 4, 1/8. Right? Then, so hence the locus is the circle with this center. Then for radius is equal to the square root of g squared plus f squared minus c. So it is going to be equal to negative 9 over 4 squared plus f squared, which is negative 1/8 squared, then minus c, which is 35 over 8 under root. Okay. So this is going to be the square root of 81 over 4 plus 1 over 64, 81 over 16, sorry, plus 1 over 64 minus 35 over 8. Let me bring it here. So the radius will be the square root of the LCM here is 64. So it will be 64. Then to reduce 45 here. So the radius will be 0.8385. So now you can easily sketch a circle with this center and this radius. How do we sketch it? You come and say this is real. This is imaginary. The center is 9 over 4 and 1/8. So if this is 9 over 4 and this is 1/8, it means that my center is here. Then we move 0.8 something units. It can be here anywhere. So if those units are somewhere like here, then you draw your circle like that. So that is what we have for that particular case. Finally, finally, there is a question that I want us to go through, and here it is. Prove that if z minus 6i over z plus 8 is real, then the locus of the point representing the complex number z is a straight line. What you need to know about this number is, if this is real, then it means that the imaginary is 0. That is what you, so you first work on this, then you equate the imaginary part to, you get the imaginary part to 0. So how do we come about this question? How do we go and come about this question? So first tell me that z minus 6i over z plus 8 is equal to x plus iy, that is representing z, minus 6i, out of x plus iy minus 8. So that is equal to x plus y minus 6i over x minus 8 plus yi. Here you have to realize this because you have I down, which is improper. So x plus y minus 6i, we are multiplying by the conjugate, x minus 8 minus yi. Over, do the same down, x minus 8 plus yi times x minus 8 minus yi. So this is the same as, first get this times this. So you have x squared minus which is x squared. Yes. I think this is plus 8. I'm using is plus 8 plus 8 plus 8, yeah. So it is x squared plus 8x. Then also multiply it here. So this is x squared plus 8x. Then when you multiply it here, you get minus xyi, xyi, all right? Xyi. Good. Then now we come to this. So it will be, remember we have this I, so it will be plus xyi. I can multiply the y later, so it is xy, okay, xyi, then plus 8y, still I, then this times this, minus 6iy, then this times this, it will be minus 48i, right? Then we also multiply this and this. So it will be plus y squared plus y squared, then plus y squared, then minus, this is negative 6i times yi. So I and I is negative, negative and negative. So we shall have plus 6y, right? Minus 6y over, when you expand down, we get x plus 8, then squared, and of course plus y squared. But remember, this is what you would get from simplifying. But we said that if this is real, then the imaginary part of z minus 6i out of z plus 8 should be equal to 0. So we shall look for the imaginary part and we equate it to 0. This positive xyi and the negative xyi, they will cancel. So we shall have 8y, another imaginary. We have 8y. I guess here there is something missing, a negative 6x in our multiplication. Because here, if you're multiplying this, it will be y xi, which is this, then 8yi, which is this, then minus 6x, this is supposed to be x. So it is minus 6x, then minus 48 should be equaling to 0. That is the imaginary. The imaginary should be equaling to 0, implying that if you have this, you'll be having 8y, you can divide it through by 2, so that you have 4y minus 3x minus 24 is equal to 0, or you can make y the subject and you say y is equal to, you bring a 3 this side, so it would be 3 out of 4x, then 24 over 4 would be plus 6. That is what you have. Alternatively, yeah, but that is it. That is the only approach I can use for that. They have told you that it is real. They have just told you that it is real. Then the number that can be similar to that, that maybe I can leave behind for you to do, is given the complex number z is equals to x plus iy. Roman 1, find z plus I over z plus 2. Roman 2, show that the locus of z plus I over z plus 2 is a straight line if or when the imaginary part, is 0. State the gradient of the line. So you can try those numbers and those exercises which I've put inside. Till next time, see you guys.